using synthetic division to find factors. All right, so here's the function that I've given you, and I would like to be able to write it out as 3 separate factors, okay? The problem is none of the methods that I showed you just up above work. It doesn't have a GCF. Grouping doesn't work on it. You can try, but it's not going to work. It's not a trinomial, right? So all the other methods that are up there just don't work on this problem. So what we're going to do is we're going to kind of guess. And I know that's not fun, but we're going to guess some numbers and send them through synthetic division and see if we can get one to work. Okay? That's what we're going to do. And because if I can get a number to work here, then I know what to put over here. Right? Does that kind of make sense? So I'm going to just guess. All right, and let me be honest with you guys. I'm not guessing. I know what the answer to this problem is. So you may have to guess a couple times, but I'm going to just sort of miraculously guess right the first time. Okay? Don't be mad. So let me erase my circle here. Hold on. Okay. So I am going to miraculously guess -1. Okay? And I'm going to send it through synthetic division. So I bring down my 1, I multiply, and I add, and then I multiply, and I add, and I multiply, and I add, and look at that. Miracle. I have no remainder, which means this is a root, right? Which means then over here, I know what the factor is. If -1 was what I put through, that means this over here should have been x plus 1. Okay, so I have one of my factors. Now, there should be 2 more, all right? And the reason I know there's 3 is because this degree is 3, all right? So I'm going to look back over here at my coefficients of my depressed polynomial, right? If I write this trinomial out that's left, hey, check that out. That thing is factorable, right? You know how to factor that. You know numbers that multiply to be 2 and add up to be 3. They would be x plus 2 and x plus 1. Okay, so that's kind of how that works. So let's try another one. Okay, just sort of a reminder, it's actually kind of really important. This one is going to have a placeholder, right? I have a cubed term, I have a squared term. I do not have x to the first term. So I need to make sure to have, that placeholder. So now I'm going to try some numbers. I don't know, let's try -1, okay? And maybe it works, maybe it doesn't. I'll be honest, guys, I don't remember the answer on this one, so I'm actually guessing. Okay, so I bring down the 2, I multiply, and I get -2, which gives me when I add -5. And then I multiply, and I get +5, which I add, multiply, I get -5. Okay, so this one didn't work, okay? This is gonna happen to you also. This one didn't work. I'm gonna actually erase some stuff, and we'll try a different number instead of -1. Okay, let's try +1. All right, so let's see. I bring down the 2, I multiply, I get 2, that's -1. Multiplying, I get -1, which I add and multiply. There it is. All right, so if this went through synthetic division and gave me a remainder of 0, that means that x minus 1 is one of my factors, okay? And there should be 2 more. All right, so the 2 more I'm going to get from this depressed polynomial. All right, so let's see. Are there numbers that multiply to be -2 but add to be -1? Yes, there are. Then I divide by the leading coefficient. I reduce where possible. And if I I can speak. If I read these bottom to top, I get a factor of x minus 1 and 2x plus 1. All right, so that's how you use synthetic division in order to help you factor.